Welcome to another video. In this video, we want to talk about units and dimension. This is an applied question. Given that f is equal to k into the square root of t, this t is a tension, k is a constant, f is a frequency, then m signifies mass per unit length, where f is frequency, t is tension, and m is mass per unit length. Prove that the unit of k is per meter. So all we need to do is to write the units of each of those parameters out. So first and foremost, we are going to say f, which is our frequency, and the unit of frequency is x. So now x is just a representation for frequency. So what makes up frequency? Frequency is made up of from wave equation. Velocity is equal to frequency times wavelength. So what does that imply? If I make frequency the subject of the formula, frequency is equal to velocity over wavelength. So frequency is equal to unit of velocity is meter per second. All over unit of wavelength is meter. So when meter cancels out meter, we are left with per second. So I can now rewrite this frequency in this context by per second is equal to k into the square root of, now T is a tension, tension is a force. The unit of force is mass times acceleration due to gravity. So the unit of mass is kilogram, the unit of acceleration due to gravity is meter per second squared. Then the unit of this m signifies mass per unit length. So that implies that the unit of mass is kilogram, then the unit of length is meter. So I can now simplify this and make k the subject of the situation. So if I rewrite this can be rewritten as x raised to the minus 1 is the reciprocal of x, that is 1 over x, which is equal to k into the square root of, now I can rewrite this as kilogram, then meter, then second raised to the minus 2 can be written as over second squared. Then all over this giant division divided by kilogram, then over meter. So the next line of action is to make k the subject of the situation. How do we go about that? So let's try to cross multiply. When we cross multiply, we have k into kg meter over second squared, then multiply by this existing s. That's the second. This multiplied by this expression gives this. Then 1 multiplied by this gives kilogram over meter. So what is the next line of action? I'm going to make k the subject of the situation. If I make k the subject of the situation, the quotient of k are square root of kilogram meter over s squared multiplied by second. So I'm going to divide both sides by this factor. So when I do that, I have square root of kilogram meter over second squared, then s over square root of kilogram meter over second squared, then multiply by second. Then this will definitely eliminate this, leaving behind k. Because k is what they asked us to find, the unit of k. So the next line of action, I can rewrite this as kilogram over root of what? Meter. Root of kilogram over meter means root of kilogram over root of meter from the rules of sum in mathematics. Then over means divided by. Now what we are having here is root of kilogram meter all over root of second squared. Then there is another existing second that's multiplied by that second. So in basic fractional rule from Bodmer's, whenever we are having division, we can we can invert this expression and change this to multiplication. So K is equal to root of kilogram over root of meter. Then this will alternate to what? To multiplication. Then this goes to the numerator, root of x squared over this comes to the denominator, root of kilogram meter. Then this also comes to the denominator. So what is the next line of action? The next line of action is to say that K is equal to kilogram in square root over root of meter, then multiply by the square root of x squared is x over, then this can be split as root of kilogram times root of meter. As we know from the rules of sum, we recall that root of AB can be written as root of A times root of B. So that is exactly what I've done here. I split this, then multiply by this existing second. Second cancels second. Root of kilogram cancels root of kilogram. So K is equal to, now at the numerator, nothing is left, so that is 1 over root n times root n from the rules of sum is equal to n. So if K is equal to 1 over n, so in conclusion, we cannot say K is equal to n raised to power minus 1. So that is what we are asked to prove. So prove that the unit of K is per meter. So that comes to the end of the session. So line is continuous, line is differentiable, line is integrable, but not the best measurable. It is a diet.